Today, we will be synthesizing Nano-Scale zero-valent iron using sodium borohydride reduction method. Before you conduct this experiment, make sure you have all the proper protective equipment. You're going to want to make sure you have your goggles, gloves, lab coat, long pants, and closed-toed shoes.
Here's a list of supplies and tools you will need to conduct the experiment. You will also need the following chemicals in this experiment. For step 1, you're going to want to measure 10 grams of ferrous sulfate heptahydrate salt. After measuring, you can add the salt to a 1000 milliliter glass beaker. Once you've added the salt to the beaker, you can then add 100 milliliters of your 30% methanol solution into the beaker. Finally, using a magnetic stirrer bar, mix the solution on medium speed for about 5 minutes to completely dissolve the salt. The solution should be a light greenish yellow color when fully dissolved. Before conducting step 2, you're going to want to calibrate your pH meter. After you have done that, you can put the pH probe in the ferrous sulfate solution, making sure the tip is submerged and doesn't come in contact with the magnetic stirrer bar. For step 3, add the NaOH solution by using a micropipette as you continuously keep stirring the solution in the beaker. As the pH approaches 5, you'll want to slow down the adding of the NaOH solution as you want your final pH to be 6.1. In step 4, you will first measure 3.97 grams of sodium borohydride. After that, you can use a glass or plastic vial to dissolve the sodium borohydride before adding it to the 50 milliliter volumetric flask. After adding it to the flask, you can then use deoxygenated deionized water and fill the flask to the 50 milliliter line. Cover the flask and then shake well before using. For step 5, transfer your sodium borohydride solution into a burette. Add sodium borohydride dropwise into the ferrous sulfate solution under continuous stirring conditions. Please be very slow in adding the sodium borohydride. You will see the formation of black precipitate. You know now that something is forming, something solid. You also see a lot of bubbles frothing in the beaker. It is happening because of hydrogen gas generation. Once the burette is empty, you can continue stirring the solution and cover it to allow the reaction to continue. For step 6, after 20 minutes, transfer the solution into multiple glass or plastic vials. Stir the solution before pouring it into the vials to make sure the nanomaterial doesn't settle to the bottom of the beaker. Use 95% ethanol in helping to pour all the contents into the vial. Once the vials have been filled, you can then centrifuge the contents at 3000 RPMs for 5 minutes. This process will allow the contents to separate and allow the nanomaterial to settle to the bottom. Once the 5 minutes is up, take the contents out. Make sure to dispose of the supernatant as it is considered a hazardous waste. You're going to repeat this process 3 times by washing the contents with 95% ethanol. Make sure to use the 95% ethanol to get all the nanomaterial out and into the vials. Note the wash water is also considered a hazardous waste. For step 7, you're going to use a vacuum oven to dry the precipitate in a nitrogen-enriched environment for at least 24 hours. You'll want to first remove any oxygen or air in the oven. To do this, you will first close the vents, then open the vacuum to suck out any air or oxygen. Once the oxygen is removed, you can then close the vacuum and open the vents. Slowly start adding the nitrogen to the vacuum oven and allow the nanomaterial to sit in there for 24 hours. After 24 hours, slowly allow air into the vacuum oven to prevent any sudden burning or fire. This slow exposure to air creates an oxide layer on nanoparticles that protect them from further sudden oxidation. This process is called passivation. Alternatively, you can store the precipitate in nitrogen environment. Before conducting this step, make sure you have an N95 respiratory mask, like the one shown here. For step 8, we want to grind the material with a mortar and pestle to get the nanoscale iron particles. You will want to grind the material for about 2 minutes. Once you are done grinding the material, you can then transfer the nanoparticles into a 20 milliliter glass vial. Make sure you scrape the sides to get as much nanoparticles as possible. Once the particles are in the vial, you are ready to prepare them for storage. There are 2 different ways we can store the nanoparticles. The first step we can do is by adding nitrogen gas to help prevent any oxidization. Make sure you slowly add the nitrogen during this step. The second way we can store our nanoparticles is by simply adding 95% ethanol to the vial as shown. The last step for this experiment is to weigh a portion of the nanoparticles and prepare them to be used in an experiment. Before weighing your nanoparticles, make sure you have a static gun to help remove any static electricity. This will help prevent any nanoparticles from becoming airborne, which would cause a hazardous condition. Please note that the nanomaterial is pyrolytic. Please store them and handle them with care. Also, consult your chemical safety department if you plan to transport any of the nanomaterial.